Hi, this is System Design for Shiny Developers, the comprehensive deployment architecture. My name is Pavel. I work as a senior full-stack developer at Epsilon. I write code in various different languages such as R, Python, JavaScript, TypeScript, sometimes others. I have extensive development experience in real commercial projects, so all I'm going to share today is based on my real-world experience. And I have experience working in projects with different deployment stacks, such as PositStack, Kubernetes, and Docker Compose, which is important because what I'm going to talk about today, I chose Docker Compose as the deployment tool. I will start this presentation by discussing why it's important to think about the architecture. Then I will show you a pre-recorded video of a project that I have developed specifically for this presentation. We will discuss the system design of this project, how it's deployed. I will share some useful links and resources, and then if we have time, I will show you a live demo on how to set it up and get it up and running. Why should we think about the architecture? My very personal opinion is that in the world where AI and LLM are so good at writing code, and obviously they're going to get even better, as developers, we should shift our focus from the applications and services themselves towards a higher level of abstraction and how we integrate those services into larger systems. Regardless of where the AI is going to be in 1, 2, 3 years, this is a skill that is more likely to stay with us than the ability to solve specific small problems using code. Also, I think it's useful to think about the architecture for those of us who are in departments, teams, or companies and act as, let's say, R ninjas, or as I like to call it, the startup mode. So you have created an application, you now need to deploy it internally, share with the team, but you are facing problems like authentication, monitoring, persistent storage, and you're looking for resources to help you out with that. And the answer is, of course, the architecture of software. And finally, I think it's generally useful to think beyond the application that you are developing. In our case, an R-Shiny application, it's useful to think of other components that comprise a system where this application lives. It helps us understand what falls within the scope of the application development or which features should be achieved rather by tools outside of the application. For example, user authentication and authorization. Let me now show you the pre-recorded video of the application that I have created for this presentation. You can download it from GitHub repository via the link. And here's the video. So it's a Shinyproxy deployment, which is connected to an LDAP server, which also belongs to us. As you can see on the screen, I can sign into the LDAP, connect to the LDAP, see what users we have, and then I will successfully sign in as a simple user using Shinyproxy. Shinyproxy is configured as a single app deployment, so we go directly to the app screen. Here's the Shiny app. It's very simple. It allows us to make requests to certain API services that we have in our system. And then there is a log which says, which basically says what are we connecting to and what was the result of the response. And then this whole system is monitored using Grafana stack. Here you can see that this is a very simple dashboard for Shinyproxy logs that Shinyproxy sends to a PostgreSQL database. This is real time, as you can see. Next, we have a dashboard pre-configured for Shiny telemetry, which records users' sessions, some information about the users. And finally, we have logs that are being sent by the API dispatcher. We will talk about it in a second. It's a special API service that prefaces all other API services. And finally, you can see that here, using Grafana Alloy and Loki, we have all logs that are being collected by Shinyproxy, both at proxy level and container level. They are all available in Grafana. Let's take a look at the system design that powers this entire application. So this is one big diagram that depicts everything that is happening here. Every white box is a Docker container. Every colored box is a so-called domain, which groups different services meaningfully. First, we have the authentication domain, which has LDAP server and the LDAP admin UI that you saw previously on the recording. Next, we have the Shinyproxy domain, which has Shinyproxy itself, and then Shiny apps that are being spawned every time user starts an application. Then, as a Shiny app makes a request, it first goes through cache system to check if we already have results there. You could see that on the recording as well. If not, just go back and check it again. If the value is not cached, then it goes to the API dispatcher that I mentioned before. And then the API dispatcher decides based on the request header which API service should it go to. Here we have 6 different services written in 6 different languages. They are very simple and they only exist to prove a point that when you are thinking on an architectural level, when you're developing your software, you can use as many languages as you like, as long as you can expose them as RESTful APIs and then make them communicate with each other. Finally, we have the monitoring domain, which is a simplified version of the Grafana stack. It literally only scratches the surface. It's super simplistic. However, the repository that I'm sharing with this presentation has pre-configured dashboards for Shinyproxy, Shiny telemetry, API, data connection to PostgreSQL. I hope you will find it very useful. And here we have the persistent storage. It's not really a domain, it's just a reminder that we have some data flows and some items that are persistent on the disk of a host system where we run the Docker containers, which are mounted through Docker volumes. Let's talk about the deployment. How do we get this entire system up and running? And it's actually much simpler than one might think. And it consists of 3 critical components. First, number 0, which is not on the slide, is of course Docker files. Every service is Dockerized, which means it has a Docker file declaration of the base layer or the OS that is using the files, the dependencies, everything. But then all these Docker files are built in a very centralized way through Docker Bake, which has its own Docker Bake configuration file. You can run a single terminal command to build tens, maybe hundreds of Docker images at once, which is very useful. I like to think about it as a Docker Compose, but for Docker images. And of course, we're using Docker Compose to start all those images, to turn them into running containers. And Docker Compose is an excellent tool for such deployments. It works perfectly on a single machine deployment. It provides us with the ability to expose only the services that we want to be exposed. In our case, even though we have approximately 15 services, only 3 of them are available to the user through a browser, which are Grafana, LDAP admin UI, and Shinyproxy itself. Everything else communicates with each other through a private Docker network, which is a great security thing. And finally, I'm using task file to run all the commands that we have to configure the dependencies between the commands so that one command runs another command if necessary. And task file helps me handle the cross-platform issues. For example, when we need to copy environment variables .env file from one place to another, obviously shell commands on Unix and Windows are different, so task file helps running the appropriate command based on the host OS. Here are a few useful links. I want to specifically highlight the third one. If you find this architecture setup for this project too overwhelming, then I recommend you to go read this paper that I submitted for Fuse US Connect 2025. It's about a Shiny app, and it has a chapter on system design and architecture, which is slightly more simple and much more focused on the Shiny app itself. Since we have a few more minutes left, let me show you the live demo on how to run this entire setup. So you can download the code from a GitHub repository that I shared, and then you will find this repository that at a glance really represents the domains that are shared on the architecture diagram over here. We have authentication domain, cache, monitoring, services, and Shinyproxy. And then we have 3 files corresponding to the 3 tools that I mentioned in the presentation. We have Docker Bake, which configures all targets for the Docker build that we have with their respective directories, tags, platforms, sometimes build arguments. Let me check. Like this. Then we have Docker Compose, which actually is a composite file which extends from individual compose files for each domain in case you want to run them separately. So for example, the monitoring domain has a folder for each individual service, and then it has its own compose.yaml file with detailed configuration, and this root compose file only extends from it. The only difference here is that sometimes it also defines volumes that are out of scope of the individual domain Docker Compose files, and it also defines exposed ports. I find it useful to do it like this. I have an immediate access to the information of which ports are exposed in my entire system. And finally, we have a task file, which I recommend you to read more about it at taskfile.dev, but it's a tool that allows me to run different commands in my terminal. Let me open up my terminal and do that. First, let me run task to see what available commands do I have. And of course, usually first thing that I would have to do is to build all Docker images. You can see that there's quite a few of them, and it would be very tedious to build them one by one. So this command helps me a lot. Now, when I have to start the entire system, I simply run task start, and it shows me the command that it's running. Let's see for all services to start up. So my terminal is freed up. Still waiting for that LDAP server. Right. Which is very important, because what I'm going to do right now is I'm going to head to the browser and go to the 6480, which is the address of the LDAP admin UI. I'm going to go to the setup, enter the root admin password that is defined over here in variables.env. This file configures environment variables for all services that we have. And let me just create super admin here, and then I will super admin 123. This is the only user that we have here. I won't waste time on creating another user. Let me go straight into Shinyproxy. And here, you might remember on the demo video, I logged in as Pavel Demin, but here clearly you see this user does not exist, so I'm not able to log in as that, but I will be easily able to log in as the super admin. And here the app will be working just fine, and while it's launching, let me also, oops, oh my god, let me also start Grafana. So the app works. My first request is cache miss, my second request is cache hit. If I fail it, it fails. I can make requests to other services. Gin, let's hit Express.js, Spring Boot, all good. Now I want to sign out. And if I go to the dashboard here, of course, we will see everything correctly logged in. We see the inputs that the user made. And if I go to the API dispatcher, we also see all the services that we hit and the error rate, which was 40% at one point because we crashed some requests. And if I go to logs, again, this logging thing is very much suboptimal to say the least, but it does the job to some extent. You can see that there are logs of all the files that we have, and those logs are actually stored here on the host machine. They are mounted via Docker volume. You can see that if you have access to the host machine, it might be actually easier to just check those logs like this. And that's all. I hope you enjoyed this talk. I hope that the material that I'm sharing through a GitHub repository will be helpful for you, your work, your development. And I really wish you to embrace the software architecture and think more about the overall system design. Thank you so much. Have a great day.